So 5.3 is called evaluating trig functions. This is kind of like some of it is the same, which we're going to learn how to find the sine, the cosine, the tangent of special angles outside of outside the quadrant angles, right? So in the last couple of sections, if I gave you the sine of 90 degrees, you could find it because it's a quadrant angle, or 180 or 270. But now we're going to find them of other angles that are all tied to special right triangles. So as a refresher, hopefully we know this well, but sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. And then we flip them. So you can choose to either find one first and then flip it, or you can learn to go straight to secant being hypotenuse over opposite, secant being hypotenuse over adjacent, and cotangent being adjacent over opposite. So in these scenarios, you won't necessarily always get all 6. For the most part, they'll actually ask you for one of them. And so it's better to know how to get straight to a secant or straight to a cotangent, that kind of stuff, instead of having to do the original and flip it. If you forget, you can always do the original and flip it. But it would save you time to get to know these. All right, so we start with just a generic triangle. It says find the 6 trig functions. So if I'm given 2 sides of a right triangle, I can either use a squared plus b squared equals c squared. Or in this case, if I've learned my triples, 7, 24 goes with what? 25, and it saved me a ton of time. So then sine opposite, which would, so sorry, I'm going to say this is A, this is B, this is C, and we're going to find of A. So put A at the top. Sine of A would be 7 over 25. Cosine of A would be 24 over 25. Tangent of A would be 7 over 24. Cosecant of A, God bless you, would be 25 over 7. Secant of A would be 25 over 24. And cotangent of A would be 24 over 7. So nothing new there, okay? Yeah.
Is 7 adjacent?
7 is, I put A at the top. So if of B, it's adjacent, but of A, it's opposite. If it was B, then the cosine and the sine would be reversed, and the tangent and the cotangent would be reversed.
So it would be 24 over 25?
For sine, yeah. So theta will either be on there or they'll label it like that, and they'll give you a specific angle. Good so far. All right, so this time I'm going to put theta in the bottom right corner. Now find the 6 trig functions of that. So you do this one. All right, so for this one, the first thing we have to do is find the missing side. It would be 1 squared plus x squared equals 2 squared. 1 plus x squared equals 4. X squared would equal 3, and x would equal the square root of 3. And again, normally it's plus or minus, but when you're dealing with the length of a side and it's not in the circle, so you don't have direction, you'll always make it positive. So this would be square root 3. So if I want the sine of theta, I would get opposite the theta, which is 1 over 2, the hypotenuse. The cosine of theta would be the square root of 3 over 2. The tangent of theta would be 1 over square root 3, and that gets rationalized to root 3 over 3. Good so far? Okay, then cosecant, I'm going to flip the 1/2, that's 2. Secant, I'm going to flip the root 3 over 2, so I get 2 over root 3, and that gets rationalized to 2 root 3 over 3. And then cotangent, I'm going to flip, but I'm going to go back to before I rationalize, so it's just root 3. So you're going to deal with ones that have square roots. You're going to deal with ones you have to rationalize. Questions on that one? All right, now these two special right triangles are going to become your best friends. Hopefully we remember these from geometry, okay? But if not, they have to get pulled back to the front of the brain, okay, from the back burner. The first is a 45, 45, 90 triangle. In a 45, 45, 90 triangle, we initially make this A, and A root 2 when you're dealing with any combination of sides. But with these, we are saying what happens when A is 1. So instead of it being A and then A root 2, we make that 1, 1, and 1 times root 2 or root 2. So this is what would happen if my radius was 1. In a 30, 60, 90 triangle, we would normally get opposite the 30 is your A, opposite the 60 is your A root 3, and opposite the 90 is your 2A. But again, in these, we're making the radius 1. So if the radius is 1, then it just becomes 1, root 3, and 2. Okay, so they will look like this. This is similar to our quadrant angles, except that they're not quadrant angles anymore. So we knew, hopefully, we remembered that if they were quadrant angles, we would make the radius 1. So same case here. If you're given a degree measurement, whether it's 30, 60, or 45, you're going to use those special triangles. So if it's 30, I'm using a 30, 60, 90 triangle. I don't care where you put the 30 and where you put the 60, as long as opposite the 30, you put your 1. Opposite the 60, you put your root 3, and opposite the 90, you put your 2. Now we blend together SOHCAHTOA with the special right triangle. So sine of 30, the 30 I put on the bottom left here, opposite 30 would be 1. The hypotenuse would be 2. Cosine of 30, adjacent to 30, root 3, hypotenuse 2. Tangent of 30, opposite is 1, adjacent is root 3, and that gets rationalized to root 3 over 3. Then I flip them, or I do hypotenuse over opposite, which is 2. Hypotenuse over adjacent would be 2 over root 3, which gets rationalized to 2 root 3 over 3. And flip the tangent before we rationalized, or do adjacent over opposite, and it's root 3. Those will never change. So you could literally memorize those 6 answers. Or you could set up your triangle. Questions on that one?
When do we use the special right angle?
That is a special right triangle. 30, 60, 90.
Oh, when it has 30, 60, 90?
When it has 30 or 60, yeah. And then when it's 45, we use the other one.
This first one is the test on Wednesday?
Yep. All right, so now we're doing it, but we're doing it at the 60-degree angle. So now I'm looking at the angle at the top here. Opposite the 60 is root 3, hypotenuse is 2. Adjacent to the 60 is 1, hypotenuse is 2. Opposite 60 would be root 3 over 1, which is root 3. And then we flip them. 2 over root 3, which is 2 root 3 over 3. Flip 1 over 2, I get 2. Flip root 3 over 1, and I get 1 over root 3, which is root 3 over 3. So if you were to compare these two, because they are complementary angles, these two switched gives you this one. So if I switch the sine and the cosine of 30, I get the sine and the cosine of 60. And then tangent and cotangent swap to give you the 60. So you swap sine and cosine and cosecant and secant because those would also swap. Only because these are complementary. Only because these are like two angles that in my right triangle, obviously the opposite side of one becomes the adjacent side of the other. And again, with the 60, all those will always stay the same. You could either memorize them or you could set up your triangle.
What about for the one with the 45s?
We're going to get to that next. Good segue, Edward. Now we go 45. So in our 45, 45, 90 triangle, it's isosceles. There are two sides that have the 1s, and the hypotenuse has the root 2. So when I ask for the sine of 45, it doesn't matter which one you pick. If you want to pick the bottom one, pick the bottom one. If you want to pick the top one, pick the top one. They'll always give the same answer. Opposite would be 1 over hypotenuse root 2, and that gets rationalized to root 2 over 2. Cosine is also 1 over root 2, or root 2 over 2. Tangent is 1 over 1, which is 1. And then we flip them, but we go back to before we rationalized. So the cosecant is root 2, the secant is root 2, and the cotangent, cotangent is 1.
What is this an example of?
What do you mean? Like you'll get a question just like that. Like your test could say, give me secant of 45. Question so far? Okay, so now what happens if we move outside the first quadrant? And this is where we get something called a reference angle. So all of those would be first quadrant because they're all between 0 and 90, okay? But we can establish a special right triangle in any 4 of the quadrants as we move around. So what you're going to do is figure out what's called a reference angle. And then based on that angle, you can set up what we just did. And then the last thing you're going to do is attach its positive or negative sign to it, okay? So by definition, a reference angle is the acute angle. That is the distance between the angle and the x-axis. So remember when we drew all of those triangles as we moved around our circle in the last couple sections, we always put theta from the end of the angle to the x-axis. It's the same concept here. So in the first quadrant, because we go from 0 to 90, the reference angle is the angle. There is no need to find a reference angle. If it's 60, it's 60. If it's 45, it's 45, okay? As you go into the second quadrant, to find the reference angle, you do 180 minus the angle. So if my angle, let's just say my angle was 100 degrees, that puts me in the second quadrant. I would do 180 minus 100, and my reference angle, which will be theta with a little tick mark, like an apostrophe, and that's called theta prime, would be 80 degrees. They will all be 90 or less than 90 degrees. When you go into the third quadrant, it is the angle minus 180 degrees. So now you could get something like 200 degrees. I know that puts me in the third quadrant, and my reference angle would be 200 minus 180, which is 20 degrees. And then if I go into the fourth quadrant, my reference angle is 360 minus the angle. So if I had 300 degrees, my reference angle would be 360 minus 300, which is 60 degrees. So the first thing you're going to do is figure out which quadrant it's in, then use the rule for that quadrant to find the reference angle, and then set up your triangle from there. The other thing you want to remember is all students take calculus. That is which of the original trig functions are positive. So in the first quadrant, they are all positive. In the second quadrant, it would be sine, and it would also be cosecant because it's its reciprocal function. In the third quadrant, it would be tangent and also cotangent because it's its reciprocal function. And in the fourth quadrant, it's cosine, and it would also be secant because it's its reciprocal function. All right, so there's two parts to this. First of all, it says sine of 210. So I'm going to use the 210 to get my reference angle, figure out what quadrant it's in, figure out what my angle would be. Then I'm going to set up my triangle, and then I'm going to find the sine of that angle. So 210 would be in what quadrant? The third quadrant. So how do I find the reference angle in the third quadrant?
210 minus 180.
Good. So 210 minus 180 is 30 degrees. So I'm finding the sine of 30 degrees, but in the third quadrant. I don't have to draw it in the third quadrant as long as I remember that it's in quadrant 3. I could draw it just like my regular triangle. That's 30, 60, 90. Opposite the 30 is 1. Opposite the 60 is root 3. And opposite the 90 is 2.
How do you know where to put the 30?
It doesn't really matter as long as you put the 1 opposite it. So what's the sign of 30? 1 over 2. That's the value part. Now we got to figure out the positive or negative part, and that's where my all students take calculus come in. So if it's in the third quadrant, is sign positive or negative? Negative. That's it. So 3 parts to it. Locate its quadrant. Find its reference angle. Actually 4 parts. Locate its quadrant. Find its reference angle. Draw the triangle. Figure out your positive or negative sign. Yeah.
So it could be square root 3 over 2.
If it's 60.
Oh, wait, so. What if the 30 was on the top though?
But opposite the 30 is still always 1. So 30, sign of 30 is always 1 over 2. Because opposite the 30 will always be the 1. And the hypotenuse will always be the 2. Yep.
What did you say the steps were?
So step 1, figure out the quadrant. 2, based on the rules of the quadrant, find the reference angle. 3, set up your triangle. And do the SOHCAHTOA. 4, determine the sign. Based on all students take calculus. Okay, so where would 300 be?
Wait, so all students take calculus if it's in like their thing that it's positive?
If the letter, if it's S in the second quadrant, that's sign. So sign is positive, the other one is negative. But sine and cosecant, because the reciprocal functions take on the same characteristics. So look, we'll jump to this one, right? If it's tangent in the in the fourth quadrant, is tangent positive or negative in the fourth quadrant? Negative.
Okay.
So my answer is going to be negative. Yep. Okay, so it's 300, puts us in the fourth quadrant. And in the fourth quadrant, how do I find the reference angle? 360 minus the angle, and I get 60 degrees. I set up my triangle. 30, 60, 90. It doesn't matter where you put it. Opposite the 30 is 1. Opposite the 60 is root 3. Opposite the 90 is 2. But now I go opposite the 60 to get tangent. Opposite 60 would be root 3. Adjacent would be 1. So root 3 over 1 gives me a tangent of root 3. And then it's in the fourth quadrant where cosine and secant would be positive and everything else is negative. All right, 675. What do I got to do first? Let's find a coterminal. So subtract 360, and I get 315. Where's 315? Fourth quadrant, right? Because it's bigger than 270, in between 270 and 360. How do I find the reference angle in the fourth quadrant? 360 minus 315, and I get 45. Now I set up my 45, 45, 90 triangle. 1, 1, and root 2. They're both 45, so it doesn't matter which one you pick. Let's pick the bottom one. Opposite is 1. Adjacent is 1. So the tan at 45 would be 1. And fourth quadrant, positive or negative?
So there are multiple answers?
No?
Negative. Oh, it's because never mind.
Yeah. Question on that one. All right. Cosine negative 240. What am I going to do first? Do you want to deal with a negative? 360. Let's find a coterminal that's positive, right? So that would be 360 minus 240. 120. Where's 120? Second quadrant. What's the rule on reference angles for the second quadrant? Well, yeah, but what's the rule on the reference angle? 180 minus 120 and 60 degrees. I'm going to go back up to the triangle I already drew because 60 is already there. Cosine of 60 is what? Adjacent over hypotenuse and 1/2. And what's the sign, positive or negative, for cosine in second quadrant? Negative. Good so far. Negative 1/2 because it's in the second quadrant. All right, now what changes with, well, 10, 11, and 12? What's different? Now they're the reciprocal functions. Everything else is exactly the same. It's just at the end we have to flip it. That's all. All right, so let's go secant. Secant of 210. Where's 210? Third quadrant. What's the rule on the third quadrant? 180. And I get 30 degrees. So my advice is in the homework is draw yourself 130, 60, 90 triangle and 145, 45, 90 triangle and just keep reusing them. 1, √3, and 2. So secant is, you can do this two ways. Either find the cosine and then flip it, or know that secant is hypotenuse over adjacent. Doesn't matter how you do that. Hypotenuse over adjacent would be 2 over √3, and then you rationalize 2 √3 over 3. And all students take calculus. What's the positive or negative sign for secant and cosine in the third quadrant? Negative. Questions on that one? All right, cotangent 135. Where's 135? Second quadrant. Rule in second quadrant on reference angle? 180 minus 35, which is 45. Hint, if it ends in a 5, it's going to be 45. So now I have my, again, I would recommend drawing one of each. So I'd have my 45, 45. This is 1, 1, and √2. Yeah. Say again. Oh, it should be 135. Sorry, thank you. And then cotangent is the reciprocal of tangent. So it's adjacent over opposite. And that's 1. And in the second quadrant is tangent and cotangent positive or negative? Negative. All right, so 12, 210 is in what quadrant? Third quadrant. Reference angle there, I'd subtract 180. That's 30 degrees. Cosecant's the reciprocal of sine, so it'd be hypotenuse over opposite.
-2.
Good, so, well, in 30, opposite would be 1, hypotenuse would be 2. So 2 over 1. And then all students take, calculus tells me it's negative. Questions on that one? Okay, 13 was negative 510. You had to add the 360 twice, or 720 to get 210. 210 is the exact same angle we just used. So I know it's third quadrant again. And this time it's the sine. We just found the cosecant, so you literally could just flip it. That's 1/2, and it's third quadrant, so it's negative. Questions on that one? Okay, and then 14, you had to add 363 times to get it to be positive. It's 60 degrees. That means it's in the first quadrant. In the first quadrant, everything's positive, and because it's tangent, and it's 60, it'd be opposite over adjacent, which is √3. Questions?
On its test, would I be able to do it as √3 over 1?
Sure. Yeah. All right, we're going to stop here, and I'm going to save the last 2 slides for like tomorrow. It kind of blends into tomorrow's lesson. The homework for tonight, and it is due tomorrow, I told you to stop at 95. So 95 is where it switches into the new stuff that we didn't get to. So up until that point, you want to complete it, okay? And then again, it's due tomorrow morning. I just said stop at 95. Everything before that you could do. No, it just like skips around a bunch. It's a PDF. you turn in up to 95. Yeah, yeah, which is like, eliminates like the last page. Yeah.
How'd you do number 14?
I